Welcome to the Stormsurf video surf forecast of the week starting Sunday, November 8th. Taking a look at significant wave heights for the North Pacific Ocean, we see not a whole lot going on. High pressure in the central part of the North Pacific is creating a bit of a gradient with low pressure inland here, creating winds and a little bit of seas off of the Pacific Northwest, but nothing of any particular interest. And low pressure in the Bering Sea is creating seas there, but completely landlocked by the Aleutian Islands. Let's dive into the details. First, we'll take a look at jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when those gales do form, help direct their track. Currently, we are under the influence of the inactive phase of the Mjo, which is pushing the jet stream well to the north. And you can see that here, pretty much pushing off the Kuril Islands, displaced way north from where it was earlier, down off Japan, and heading directly over the Aleutian Islands, tracking almost up into Alaska, and then falling into a bit of a trough here off the U.S. West Coast, but so close to land to not really have any support for gale development. Let's put this into motion. We watch this same basic pattern continue. Another little trough Tuesday. That is a dip in the jet stream heading south, helping to support counterclockwise flow in the upper atmosphere and down at the surface, and that is the hallmark of low pressure. So that little gale, or at least potential for gale on Tuesday, is on the charts, but again, it just goes quickly inland. And then there's yet another very north displaced gale forecast or support for that in this pocket of energy here in the Gulf come about Thursday. But again, just not getting much push down further south, all tucked up close to land and well displaced to the north. And then we get into Sunday, late Sunday, a week out, and again, there's this sort of split in the jet stream going on and just not good organization. A bit of a trough here trying to organize come Sunday in the Gulf of Alaska, but just nothing that would really catch your eye and go, oh, this is an El Nino supported jet stream flow. That is not in play at all, unfortunately. Next, we take a look at surface level pressure and surface level winds. And what we see is high pressure, a very strong high pressure at 1036 millibars off the U.S. West Coast, north of Hawaii, and then weak low pressure inland here. The difference in pressure is creating a pressure gradient and north winds 230 knots in one small little pocket here at 18Z on Sunday, and creating some seas, but just nothing of real interest. You need at least 35 knot winds. They need to be over a decent size area, and they need to persist for at least 18 hours to really get some decent sea development from that. Anyway, roll this out. High pressure remains the name of the game, and this sort of gradient thing going on off the U.S. West Coast into Monday. And then we see low pressure trying to organize Tuesday up in the Gulf. 30-knot winds aimed mainly towards Vancouver Island, but certainly the Pacific Northwest will see something from that. That sort of fades out. And then a much stronger system Wednesday. Actually, let's go back. It starts right about there, late Tuesday night. We see 55-knot winds, but most of that is up in the Bering Sea and landlocked by the Aleutians. And then it tries to get better organized. You can see it at 18Z on Wednesday, late Wednesday morning. 55-knot winds finally working their way free and clear into the Gulf of Alaska and continuing for the next 6 hours past that, and then down to about 45 to 50 knots and slowly fading out into late Thursday. Persisting something, but mainly this is very north-angled swell all for the U.S. West Coast. Hawaii is completely out of the picture in terms of getting anything from that. Then we roll this out and just more of the same, kind of here, another big high pressure system rolling in 1036 millibars on Sunday. That's a week out, and some sort of low pressure. We know there's a trough trying to set up here, a little bit of low pressure, but just nothing to write home about. All this looks very much like the inactive phase of the Mjo and very much not like El Nino. So next we take a look at significant wave heights for the North Pacific Ocean. What's the effect of those winds at the surface on the ocean? And we saw this chart already. We'll roll this out a little bit. We see continued seas in the what is that, 16, 18-foot range off the U.S. West Coast on Monday, and then that fades out. And then eventually we see some sort of sea development trying to get going here. Late Tuesday, 18-foot seas here in the eastern Gulf of Alaska, again targeting mainly the Pacific Northwest with wind swell, and that'd be about it. And then finally we get into, what's that, Wednesday. We see 32-foot, it says 34-foot, but the reality is it's maybe one Grib square. So basically 32-foot seas starting to develop Wednesday a.m. Right south of the eastern Aleutians, building quickly. What is that? We get up to 46-foot seas over a small area, but free and clear in the Gulf of Alaska, certainly aimed at Vancouver Island, down into the Pacific Northwest, and certainly swell will at least radiate to Point Conception, assuming this plays out as forecast. And then things sort of fade out, but still you have 43-foot seas into Thursday, pushing east, and then slowly the system fades out with a little bit of secondary fetch here on Friday, creating more, what is that, 22, about 26-foot plus seas or so. Certainly, if that were to happen, it would be good for swell again into the weekend. It looking long range, assuming one believes the models. And then after that, you can just see high pressure here, some sort of a cutoff low below that, all creating fetch aimed at Japan, nothing at the U.S. West Coast. And we'll just roll this out into late Sunday. And again, just things not really cooperating as we would like. And we'll just take a real quick look at the southern hemi. For the most part, it has shut down and it's done for the season, but you never know. Late season storms can form, and one is projected here on Tuesday. Small area of 40-foot seas building to about 42-foot seas. Some flavor of this has been on and off the charts here for now the past 4 or 5 days. If it were to form, the cutoff really for Southern California is right around in here. So yes, perhaps some small sidebands. Well, most of the energy is really targeting Chile, so maybe a little bit of dribbles into Southern California, certainly more for Mexico and down into South America if it were to form. And then after that, that's pretty much it. Things are over. A little bit of a cutoff low here, maybe targeting Tahiti with small swell next weekend, if one would believe the models that far out. So for the most part, Southern Hemi pretty much over. The focus is North Pacific, and we're just waiting for it to waken up. Unfortunately, it's not expected to do that for the next week. Let's find out why. So we'll talk about our El Nino. We'll also talk about the MJO, and we'll talk about anything else that can contribute significantly to the long-term surf forecast. So we'll do like we've done in weeks past. The focus is first the Kelvin Wave generation area and winds in the Kelvin Wave generation area. That's here basically around and west of the dateline, just a couple degrees either side of the equator. West winds or west anomalies in this area help push warm water, and we see warm water there, off to the east, which creates a Kelvin wave. That is a blob of warmer than normal water that travels under the equator down about 200 to 300 meters the whole way across the Pacific, and then finally erupts over the Galapagos and into Ecuador, creating a warm pool at the surface there, which then gets caught by trades and migrates back to the west. And that warm pool, when it works its way almost to the dateline, the Nino 3.4 region, they call it, from about 170 west to about 120. So in here, if you have a lot of warm water there, warmer than normal for the time of year, then that helps alter the jet stream, and that is the hallmark of El Nino. Currently, this is from actual buoys down at the ocean surface. We see really, one or two little arrows that maybe suggest a light drift of west winds, but certainly no strong west winds whatsoever. But in regards to what's normal for this time of year, we still see westerly anomalies. This is differences from normal for this time of year. And right where most of it now, notice, is east of the Kelvin Wave generation area, over here south of Hawaii, when you really want it back here. Let's go take a quick look further in. So here is the Kelvin Wave generation area proper, right here in the dark or in the solid line box with outer periphery, the dash lines. The date line is right here, New Guinea's here, so it's pretty much from about 135 east to the date line, a little bit beyond. And clearly we see right now basically a stagnant air pattern. Here's one little pocket of westerly anomalies to maybe 10 knots. I mean, these aren't actual westerly winds to 10 knots, but nothing wholesale, nothing large. But notice this, as we get into Monday, that little pocket starts blooming. This was not forecast until just about 2 days ago. It started showing up on the charts. This is a very good sign because this really isn't supposed to be here for some of the other models we're looking at. This is a 14-knot westerly winds, and it sort of comes and goes in that area. And then here's more westerly anomalies showing, or westerly winds showing up on Wednesday, Thursday, this whole area right in here. It sort of looks like a broad area of low pressure setting up. And here we go. It just continues. This is exactly what we want to see. It's actually growing in coverage too into Saturday. And then we see more westerly winds start building here. This is, if there was a strong El Nino-based state in play, this is exactly what we'd be expecting to see as the norm, and this just continues out through the 180-hour period. And here's the east quadrant of the Kelvin Wave generation area from the date line to about 165 west. Hawaii is just up here north, outside of the picture. Anyway, we'll roll this through. We're just looking in this box. Basically, it is calm winds, little hints of westerly winds, but basically calm the whole way through, or just a light east tendency, which is pretty much normal. And we'll roll this out. Here we go. And that is pretty much it. So not a whole lot going on there. It's mainly in the Kelvin Wave generation area proper that we're seeing westerly winds making a reappearance. This is a good sign. And here's a quick review. Westerly winds, the Kelvin Wave generation area is pretty much right in this area here. And you can see there's no westerly anomalies, or has been since pretty much November started. And we roll this down, we see right here on the date line this pocket, but other than that, the pattern has been pretty quiet the past week. That is not conducive to Kelvin Wave generation, and that's what we want to see, is more warm water being transported to the east. Here's another way to look at it. The Kelvin Wave generation area runs roughly from here to about here. This is time, going back in time, working our way to the future. Here was the last big westerly wind burst that occurred in early to mid-October. It has created a Kelvin Wave. This is westerly wind burst number 4 of the year. A very solid one indeed. We'll talk the details in a minute. Now notice here, this other bit of westerly anomalies that occurred late October is actually, for the most part, this is the international date line right here. Most of it is all east of the date line, and for the most part outside of the Kelvin Wave generation area. Also notice there were easterly anomalies that started showing up here, and fairly strong right on the hairy edge of the Kelvin Wave generation area. That is not what you want to see, but that is also a suggestion that the inactive phase of the MJO was in control. And we roll down, here we are today, and this sort of just weak nothing pattern going on, and no westerly anomalies. And then here's the forecast for the next week, and here's the beginning. You start seeing the westerly anomalies start to build. This is 150 east here, so the Kelvin Wave generation area goes off to here, and what this suggests is about a week out, we're back into the standard El Nino kind of mode. The thought being that once these westerly anomalies get more entrenched and start getting a better foothold, that the jet stream will start falling further south, and that we'll be back into a more conducive pattern. And whatever this, we'll call it the inactive phase of the MJO, and clearly it has that signal. This is a bit of, basically the thought is that we had this giant westerly wind burst, and then the atmosphere took a break and said, hey, we got to regroup for a little bit. So it turns inactive, and now the thought is that it will start regrouping. The El Nino base state will take over again, and we'll be back in business. We just got to get through about the next week or so, and then things will start shaping up. And here's the projection from the CFS model, and it's showing much the same sort of picture. It's actually looking much better than it did a week ago, which is good news. So Kelvin wave generation area, again, runs roughly, draw a line right down here to about and right up here, so that's the date line right there. And again, now this is going different scale back in time here. Big westerly wind burst in July. That was westerly wind burst number 3 that created Kelvin wave number 3 that's erupting now. This was westerly wind burst number 4 that we believe has created Kelvin wave number 4. It is nowhere near erupting yet. And then somewhere about right when we got to the end of October, that's when the westerly anomalies pretty much died out. And you see here, just looking at westerly anomalies, come about Thanksgiving is when things start getting back in business. But notice if the date line is running right up here, it's kind of on the date line region, but starting to move a little bit to the east. But as you get into the December time frame, then it takes up just more right on the date line. So let's put some of these things. Here's your Mjo signal, and this pretty much explains active phase of the Mjo, westerly wind burst. Inactive phase of the Mjo, things die out, the active phase starts working its way in, and we'll get into a little bit more here. And once you get into the December time frame, that's when things are really supposed to start hopping again. There's also equatorial Rossby waves, and there we go. And that's happening right now, but with the Rossby waves tend to constructively interfere or help support westerly anomalies, but with the inactive phase, the MJ there, it's not doing anything. They're sort of canceling each other out. But when the active phase starts working its way in later part of November, then we're kind of back in business. How much I believe any of this? Hard to say. This is the interesting part here. This is the overlay of actual El Nino base state, and it suggested that the very peak of the base state was basically over Halloween, but that we're continuing very solid. I mean, we're talking one little circle there, one little closed isobar, or whatever you want to call contour. But still very strong into even February, the signal, not decaying significantly. If anything, notice it's been building the whole way and not to decay out. Don't know if we believe any of this, but long term, it looks good. For the short term, even that starting about a week or so out, 2 weeks out, we should be back in business in the worst case, which is exactly what we want to see. So we've talked about westerly winds. We say westerly winds help create Kelvin waves. So now let's go look at the ocean, below the ocean surface, and see what's going on. And we have a very perplexing problem here. So these are the anchor lines for the TAO buoy array, and they're supposed to be evenly spaced. And notice once you get to about 170 west, you get east of there, there is virtually nothing. There's a couple of sensors active here, but just a couple days ago, this whole area basically died out, and this picture all of a sudden makes no sense anymore. Some of it's sort of believable, but a lot of this is not. So this is actual water temperatures. We're pretty much saying, I don't know that any of this is true. I can't trust it. It's just made up because there's no hard data here. Likewise, the anomaly picture, this is differences in normal for that time of year. You can clearly see where there are sensors, and you can clearly see there's just a big old hole here. This was looking good. It suggested 7-degree anomalies in this area here, and now the picture's all fragmented. Doesn't make much sense. Yes, you can sort of tease out because there are bits. You could sort of really, if you were to assume that all this was active, all these sensors were active, that actually what they're seeing here, this should be one consolidated giant pool of warm water. But in terms of being able to tease out the details, I mean, we were down to measuring every day where the 4-degree anomalies were, 3-degree, et cetera, et cetera. Can't do any of that now because this is all just basically we've lost visibility into this situation. Now, the hope is that NOAA, I know they have ships scheduled down here to service these, but I don't know what the details are, but I do not believe that it is anytime soon. This is a significant journey to go out and logistically plan to service all these buoys. So I think the situation is we're going to be flying blind for the rest of this El Nino, unfortunately. Now, there is another view of this, and I'm not sure where they get their data from. The sense is that it's not all from the TAO buoy array, and so there's multiple competing agencies within the government that produce, that have their own technologies and their own ways of doing this. So we'll go to this picture. This picture suggests a very robust giant Kelvin wave in play with more warm water flowing down into it. This is basically a reservoir. This is warm water from Westerly Wind Burst number 3 and Westerly Wind Burst number 4. Also note that finally 4-degree anomalies are starting to work their way up towards the surface again at 100 west and about 115 west. So when we go inspect the surface level pictures, we would expect to see warm pockets showing up on the surface there. So overall, the assumption is the underlying subsurface profile is extremely positive. And that can be confirmed. Here we go now. This is from the JSON-2 satellite. You strip out all the waves, all the chop, the tides, any other sort of interference, and just get to the actual height of the ocean surface. They can measure to within a centimeter or two, and we see there is a big bulge here. This is the biggest bulge we've seen so far in years, probably since the 97 El Nino, 20 centimeters above normal. What this suggests is that there is warm water at depth. Warm water expands, therefore creating a sort of a bulge on the ocean surface. So if you measure the bulges, you can kind of get a sense of what's going on underneath. And this correlates well with the previous image we just displayed that shows massive amounts of warm water from just shy of the date line the whole way into Ecuador, with the main focus right out here between about 100 and about south of Hawaii. And this is actually built in the past week, again confirming there is a very large pocket of warm water at depth here. And we really like this chart here. This is upper ocean, the top 300 meters of ocean temperature, anomalies from normal, because literally you can see the Kelvin waves going. Here's the West Pacific, here's the East Pacific in time. Last year, 1 Kelvin wave. Then we get into this year, Kelvin wave number 1, number 2. Here's Kelvin wave number 3 that's erupting right now. That was in the, and this is created from very strong westerly wind burst in the late June, July time frame. Now here's the cool part. Here we are now. This is Kelvin wave number 4. Very significant here. So if you actually start measuring the distance at any point in time, because every day they basically add a new row of pixels to this image. So this guy here, this Kelvin wave, had a max width at any one point in time of about 30 degrees. These are 10-degree increments, 1, 2, 25 there, somewhere down in here, 1, 2, there was 30 degrees, that was the max. So that's at 60 nautical miles a degree, so what's that, about 1,800 nautical miles. Here's our new Kelvin wave. We thought this was a monster. This guy comes along, look at this, 10, 20, 30, 40 degrees in width on the equator, 2,400 nautical miles of water that is 2.5 degrees or more above normal, and that's in the entire column going down 300 meters. So very much warm water. This sort of supports what we saw up above. Now, how they're collecting this, we're hoping that it's not using the TAO buoy array, but they have some other technology to do it, and maybe it's a mixture of a bunch of technologies. But either way, this is actually much better than expected. We knew this was a solid westerly wind burst, but per this chart and per the JSON-2 image before, this one is bigger than Kelvin wave number 3. Bring it on. There's good news associated with this. So assuming this was created in the, what would we say, let's say mid-October time frame, 2.5 months to get its way over to the Galapagos. So we're talking about Christmas time. It starts erupting, and then a month after that, so late January is when it's actually going to start migrating in the Nino 3.4 region on the surface. So that's when the max impact on the jet stream would be, is in the late January time frame. And this guy's going to town already. So, this inactive phase of the MJO that we're going through, yes, it's a little bit concerning, but the reality is this warm water we believe, will not be denied its impact on the atmosphere. We just have to be patient and wait it out. 97 was a very strong El Nino. It hit very early and very strong and was just like a train coming at you. This year's El Nino is kind of, it starts and stops and starts and stops, but its impact on the ocean is undeniable in terms of the warm temperatures that it's generating, and we believe its effect on the atmosphere is coming. You just have to be patient. So we've talked about surface level winds, that is differences in normal, and we want westerly anomalies here in the Kelvin wave generation area. We've talked about Kelvin waves, and certainly there is one massive Kelvin wave erupting now, second one in flight, and then the impact of those Kelvin waves, they hit over here. They're formed over here, go under the equator, 300 meters down, and then eventually hit land, erupt on the surface, create a pocket of warm water. Trades in that area starts pushing the warm water off to the west into the Nino 3.4 region, which is basically bound here to here. And when you have warm water there, especially as warm as this, then that is supposed to affect the jet stream and start creating more storms in the North Pacific in the Gulf of Alaska in winter months. Currently, we have very warm water. This is the low res image. It's really hard to tell exactly how warm, but one can certainly say warm water. Let's go back a month. Here's what it was, and here's what's happened in a month's time. Gotten much warmer. I mean, very impressive. Not comparable to the 97 El Nino, which was even more so, but very solid indeed. Let's get into the details. So we'll go quickly sector by sector. Nino 1.2 region, that is close to land between the Galapagos and the Ecuador. Temperatures, again, very not impressive in this area. Yes, in any normal year, if you saw these 2.25 degree anomalies here, you go, wow, that's pretty impressive. But from a super El Nino perspective, certainly not. In fact, here's where we were a week ago, and things have only continued to get worse. We're not really concerned about that because we're saying most of the eruption of this warm water is displaced to the west, basically from the Galapagos and west of there. Let's go to the next sector. So here we go. Here's Mexico here. Kelvin wave the Nino 3.4 region actually starts right here and is bound 5 degrees either side of the equator, and you look at that and you just go nothing but 2.25 degree anomalies or warmer, with one pocket of 4 there, one pocket of 4 there, and even a couple of pixels of 4 degree anomalies there, and much warmer water off to west of the Galapagos. And remember, trades are blowing here, taking this warm water, pushing it over into this region. Very impressive indeed. In fact, we go back a week ago and say, you know what? It's still growing in size. This one little finger here is flattened out, but there's been some growth down to the south. And you can see just very solid, impressive, major El Nino configuration in play. Let's go one more sector off to the west. And here we are from 160, and actually the Nino 3.4 region cuts off right here. Piles of warm water filling here. We'll go back a week. And you see, there was more girth here, but now it has stretched out, filling to the dateline and beyond. Very impressive. This is the best we've seen it so far this year. And the thought is, it's only going to get stronger from here. You saw what the subsurface configuration is. You see how much warm water is at depth. It's working its way up to the surface. There's just a giant pool of warm water that's going to continue to feed this surface warm pool. And yet one other view, this is a good one because it seems to highlight those 4 degree and 5 degree pockets. So here's where we are right now with a little pocket here by the Galapagos. So that's 1, 2, 3, 4 good solid sized pockets. A week ago, it was a little bit warmer, but still quite respectable, quite solid, and looking very, very much like at least a strong El Nino. Okay, and then let's look at this over time. This is in the Nino 1.2 region, the area we've basically written off and we don't care about. But we saw there was a big dip here in the late October timeframe. Current numbers, 2.25 degrees above normal. Very solid indeed. But it is the Nino 3.4 area that we're most concerned with. Current value, 2.6 degrees above normal. If we were to hover even in the 2.4 range and stay there for a month, that would be beyond very impressive. We're hovering in that range now. This is picking up on the warm water that the past week has been building and more. And just if you draw a line here through this, a straight line, you can see the trend is trending upwards, and we expect that to continue with all that warm water sitting subsurface and continuing to gurgle to the surface. Let's look at some other, so this is daily index. Let's look at the latest monthly numbers. So this is ERSS2V4 centered. So this is the most conservative view. The oceans, in case you don't know, have been steadily getting warmer. We're not going to get into the debate of why they're getting warmer, but they've been steadily getting warmer. So what this chart does, or what this data does here, this centered, is tries to reset what is normal for the ocean for this time, for different times of year, so you can accurately calibrate past El Nino events to current El Nino events. And what you see is, so the 98 El Nino peaked out at 2.32 degrees above normal. The 82-83, both these were super El Ninos, 2.2 degrees. The 72-73 El Nino was at 2.03 degrees. It was not a super El Nino, but just under the threshold. We are currently right here at 1.86 degrees. This would make us, in terms of any other El Nino that's ever happened in modern history, well, that's the first, second, third. This is tie for fourth. The 65-66 El Nino was at 1.87. The thought is we're clearly going to surpass that, and we're trying to get somewhere up into about the 2.1 degree range. That's our target. That's our expectation of where all this is going to end up. Maybe more. Hard to say, but that's a conservative target. If we can get into there, maybe about the 2.1 degree range, then we'll fall into very close to super El Nino status. In terms of just regular El Ninos, we're up in the stratosphere already. The game becomes now, are we going to make super El Nino status? If nothing else is, you just want to be able to say, yeah, I lived through one of those. I saw it evolve. I went week by week, day by day, and watched the progression and lived the drama. And it's sort of like a soap opera. Things come and go. You have good things and bad things, but how does it all come out in the end? You never know. It's a guessing game, and it does what it's going to do. You try to predict it, but no prediction is perfect. You just watch it as it comes. So here's where we are in good, respectable territory, and we think this is going to be more of a late bloomer, sort of like 82, 83. So we got a ways to go, and with all the warming of recent, this is the October numbers. I'm really surprised they weren't a little bit higher, but we think once we get into the November, December time frames, you're going to see much higher numbers, and then we're really going to get to, and that's where the peak of most of the El Nino season is in the December, January time frame even. We see here that the 82-83 El Nino, it was in the January, January time frame when it peaked out. So we still got the better part of 3 months to go. So a lot can happen. Anyway, this puts things into historical perspective. All right, we've talked about westerly winds, their effect of moving warm water to the east. We've talked about Kelvin waves and their means of transporting warm water subsurface to the East Pacific. We've talked about the warm surface temperatures, put that into historical perspective. But all that means nothing unless it has some impact on the atmosphere. So, coupling. How well is the ocean and the atmosphere coupled? This is the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. That gives us some sense of what's going on. If you have a long run of negative numbers, especially extremely negative numbers, then you would suggest El Nino. Just a run of moderate negative numbers suggests the active phase of the MJO. Currently, the daily number minus 8.20, not particularly impressive, but any other time, if you saw this kind of numbers setting up any normal year, you go, wow, we're in a really strong active phase of the MJO. Yeah, we are. It's an active phase of the MJO that just doesn't stop. It's called the El Nino base state. But compared to weeks and months previous, numbers are kind of rising a little bit. Nothing impressive. That's because we believe, as we saw in some other charts, in fact, we haven't shown those, we'll get into that in a second, the inactive phase of the MJO is in control. The 30-day running average has been rising too, minus 15.49, and the same thing with the 90-day running average, minus 17.62. We want to see this guy at about minus 18, this guy down around minus 20. It's given up some ground. Here's the 30-day running average put in perspective. We go back in a year, 2 years ago. Basically La Nina. We've been on a downward run for the better part of all last year, now this year. And here's the recent little run up in numbers. Still well negative. You're down in the minus 15 to minus 20 range. You're in El Nino. Clearly we are. This, we believe, is attributable to the inactive phase of the MJO. We all expect that it will continue to fall some more in about a month out. We neglected to show these charts earlier, so we'll do that real quick. So typically when you see this outgoing long wave radiation, this suggests more cloud cover, the active phase of the MJO, less cloud cover, the inactive phase of the MJO. Normally this, a month ago, was sitting here, and then you had dead clear air here. That was classic El Nino setup. Now this suggestion of the inactive phase of the MJO right in the middle of the Kelvin wave generation area, notice that, is in effect, and it's supposed to hold for 2 weeks according to the statistic model, but notice it has the active phase of the MJO starting to work its way into that area 2 weeks out. Typically during El Nino, you see no inactive active phase oscillation. It just goes dead stagnant. The dynamic model has us going from the inactive phase, and about a week out, boom, nothing, and then back to the inactive phase being where it should be, and a weak active phase setting up here. This is the preferred situation. Unknown how this will play out. And also these phase diagrams, they sort of give you a sense of what's going on in terms of the active phase of the MJO, and they suggest that, in fact, the active phase of the MJO here, the further away from the center you are, the stronger the active phase. And then depending on where you are here, either the Indian Ocean, you sort of can go around the planet this way, and the active phase tends to go counterclockwise around. Well, currently it's in the Indian Ocean, active phase per both these models in the Indian Ocean, and that's what we've seen on other charts, but it's supposed to die there, not supposed to make it east, at least per these two models. So back to talking about coupling with the atmosphere, ocean-atmosphere coupling. The stronger the coupling, the stronger the El Nino, the larger the effect on the jet stream and the storm track in winter months. And this chart sort of puts things all in perspective. The multivariable ENSO index, we talked about first the Southern Oscillation Index. Now we'll talk, this is a combination of multiple indexes all thrown together. It suggests that in the October time frame, it actually, the index fell a little bit. We really want to see this guy get up into the 3 range. You have to be up in the 3 range, 3 standard deviations above normal to be considered a super El Nino per this index. We've actually backslid a little bit, but let's be clear. Where we are is we're at the 3rd strongest El Nino ever right here. There's nothing that has been higher than that. That one is very close there. Which one is that? The brown? I can't eyeball it easily. But anyway, we were up pushing, we backslid a little bit, but still very solid territory nonetheless. And then finally, the daily ESPI index, that is sort of like the Southern Oscillation Index. You would expect to see less precipitation here, more precipitation here. The higher this number, and it was up in the 2 and the 2.4 range, it has backslid a little bit lately. We attribute that to the inactive phase of the MJO as well. And here is the monthly ESPI index. The October data has posted 2.3. Oh, hang on. Yes, that's 2.3 for the month, actually up from the September data and about equivalent to the August data. Very well standing 2.3. Compared to 97, the strongest El Nino ever, you see that in 97 in June it went up to 2.9. 2.930 in August, and then it started to fade basically from there. And what happens is the ESPI index actually leads. It comes in about 2 months or so earlier than the actual water temperatures. And you can see that here, that is the peak in the Nino 3.4 water temperatures. You can see peaks here were in the June, August, September time frame, and then it started fading off. For 2015, it was May and then July, and then has started fading off a little bit. So hard to tell exactly how this will play out. It's a little bit of a noisy index, but it suggests that we're in very good territory. And if anything, perhaps stronger. This 3.7 reading in July was stronger than anything that occurred in the 97 El Nino or in the 82-83 El Nino. So certainly in super El Nino territory per the SPI index. Again, we're going to tend to side with the MEI index for right now because it considers multiple. This is just one data point, one source of data, if you will, whereas the MEI consolidates 4, 5, or 6 different sources of data or different types of data, gives you a more holistic view. So, the quick wrap-up. Right now, Jetstream not looking particularly impressive. Storm track, yes, a little bit of a storm forecast for the northern Gulf later in the week. Again, for more north-angled swell, mainly for California. Hawaii's kind of the out of the action right now. The overview being the inactive phase of the MJO is in control. We don't really understand why, but we have accepted the fact that that is the case. The good news is it's supposed to be fading out anywhere from 2 to 3 weeks out from now. We should be back in business come, let's say about the Thanksgiving time frame. There's already suggestions that westerly winds per the GFS model are starting to build in the Kelvin Wave generation area. That might hasten the demise of the inactive phase of the MJO and get us back into a pure El Nino base state. And then from there, westerly winds, honestly, at this point, it really doesn't matter. There's so much warm water subsurface, and we saw that it's completely off the chart. The next Kelvin Wave number 4, if the data is correct and we're reading it correctly, is stronger than Kelvin Wave number 3. And Kelvin Wave number 3, very strong indeed. Kelvin Wave number 4 will kick in, and that won't be till later in the year. All this suggests that the peak of El Nino is going to be pushed off later in the year. 97 was early to rise, and then it kind of petered out. 82, 83 took a little bit longer to get going, but once it got going, it was nonstop. And so we suspect this is somewhere between 97 and the 82 events, probably closer to the 82 event. So we'll sort of peter along here for a little bit, get frustrated, but at some point the storm door is going to open, and once it starts, it probably isn't going to stop, and it probably will be fairly impressive. All the indexes and the data are suggesting we're in the, if not super El Nino category, extremely strong, one of the top, 3, probably the top 3 El Ninos in the past 60-plus years. That's a good place to be. You're probably not going to see another one like this in your lifetime. Maybe you will, but maybe not. Enjoy it. Take it. Learn from it. This is a great learning opportunity. Anyway, so that's it. Long-term forecast is still looking very good. We just got to get through this little bump in the road, and then we're back in business. So that's it for this week. We'll do it again next week. Same time, same channel. Thanks for watching.